Here are the answers for Module 12 Review number 1, the modified test. So here's the review. Number 1, what is the explicit rule for the sequence shown in the table? And so if you look at the pattern, it is going in increasing. So it's at a rate of adding 3. So it looks like the common difference is 3. And we know that according to the table, it looks like for f of 0 starts at 5, so a equals 5. So f of n should equal to a, which is 5, plus common difference times n, so that's 3n. And that's definitely answer choice A. Number 2, what is a recursive rule for the sequence shown? And according to the table, it looks like it's being multiplied by 5 to get to the next term. So we know that this is a geometric sequence and the ratio is 5. We have f of 0 is 0.1. And so it looks like the formula that matches that would be f of n equals the ratio, common ratio is 5 times the previous term. So it looks like C is the best choice. Number 3, what is the common ratio for the table shown? And it looks like it is multiplying by 5, so B is the correct answer. Number 4, Ron is selling items at a craft show. The first hour his sales are 20. His sales grow by 10% each hour. What are Ron's total sales for the first 5 hours? So remember that the ratio for 10% is going to be 1.1. So f of n is equal to a times r to the n minus 1. So this is a geometric sequence when you're growing and you're multiplying by a rate of 10%. So let's again identify the initial value, which is 20, and then the ratio is going to be increasing by 10%, which means that you have your 100% plus your 10%, which gives you a total of 110% for the new value. So convert that into decimal, that's going to be 1.1. So R is equal to 1.1. So f of n is equal to 20 times the formula ratio is 1.1 to the n minus 1. So that's the nth term, but we're not asked to find the nth term. We're asked to find the total sale for the first 5 hours. So this involves the sum. So we're looking for S of 5. So we have the value of A, R, and then N is equal to 5 in this case. So S of 5 is equal to A times 1 minus R to the N over 1 minus R. So that's going to be 20 times 1 minus R to the N, which is the ratio is 1.1 to the 5th power over 1 minus 1.1. And the rest of it, you can use calculator to get the answer. So I'm going to work it out really fast. 1.1 to the 5th power. And make that negative plus 1. So on top, I have negative 0.61051 divided by negative 0.1 on the bottom. So I have 6.1051 times 20 outside. The total, it should be 122. So that should be the total. And looks like the closest answer is answer choice C. Number 5, graph the sequence shown in the table of the values. So we're just going to simply graph when n equals 1. Looks like this is going by 2s. So 1, it's 6, which is right there. At 2, it's going to be 8. At 3, it's going to be 10. 4, it's going to be 12. 5 is 14. 6 is 16. So it looks like it's forming a straight line. So that is the graph. Number 6, consider a type of bacteria that divides into 2 new bacteria every 30 minutes. A scientist growing the bacteria in the lab begins 150. So we know the initial value is 150. Number 6, write an explicit rule that describes the number of bacteria after n times increment. So we have f of n is equal to, so it grows into 2 bacteria every 30 minutes, which means in 1 hour it's going to grow 2 times. Like in 1 hour it's going to grow 2 times. So we have the ratio is going to be equal to 2. And so therefore the equation is going to be 150 times 2 to the nth power. And that's going to be our equation. And then number 7 says write a recursive rule that divides the number of times the number of bacteria after n times. So we're just converting that formula. So we're going to start with describing that f of 0 is equal to 150, and then f of n is going to be 2 times the previous term, because it's going to go into, divides into 2 new bacteria. So it's going to be 2 times the previous. And then that's going to be n greater than or equal to 1. And also for the top, number 6, you can also start with you can also get f of n into the second formula when n equals 1. So this one is for n equal to 0. So if you want to convert it to the n equal to 1 formula, you probably need to go to the next term, which is 300, because it's going to start like 150 and then 300 and then 600, so on and so forth, right? So that's going to be 300 times 2 to the n minus 1. So either one of these formula is fine. So it probably makes more sense for this problem to have the top formula. Number 8, which equation describes the number of bacteria present 3 hours later? So every 30 minutes it divides, right? So in 3 hours, okay, there are how many 30-minute blocks? So 1 hour equals 2 30 minutes, right? 2 times 30 minutes. So times 3 hours later, that's going to be 2 times 3, which is 6 of 30 minutes. So hopefully that makes sense. So that's why the power, it should be 6. So it should be the answer for number 8 should be B, f of n equals 150 times 2 to the 6. Number 9. A geometric series has 7 terms. It begins with 350 and decreases by 0.15% or 15% for each term. What is the formula for the sum? So let's identify the initial term. So we know that A is equal to 350. And we talked about this in class. If something is decreasing, that would be a depreciation at 15%. That means your ratio should only be 1 minus the 0.15, which is 0.85. So the ratio is 0.85. And so what's the formula? And n in this case will equal to 7. So if you substitute all of this into the series formula, the answer that is closest to it is A. So that's A times 1 minus the ratio to the 7th power over 1 minus 8.85. So that's the answer for number 9. Number 10, the formula for the sum of a geometric series is given. What is the sum? So it's just basically asking for you to continue to get the answer. So I'm going to work it out. And so it should give me from here 80 times on top negative 4.0625 over negative 0.5. So I'm going to divide it by negative 0.5. And inside the parentheses, I have 8.125 times that by 80. It should be 650. So the answer for number 10 is 650. And I'm going to stop it here so then I will work out the rest of the problem in another video. So this video doesn't have to be so long.